pleasure to introduce Professor Suryakant Bhosle. He's from Mumbai, and he has had a long career building lots of hardware experience. So I'll let him talk to you about his experiences and his latest inventions and so on. So Professor Bhosle.
Thank you. Okay, let me begin by saying that what are we individuals? We know there are computers in the world. Some other computers have been developed by individuals like us. Then some of them have been developed by God himself. So I classify there are three types of computers exist in the. One is called GMC, which is God-made computers. Like all of us are God-made computers. Then there is MMC, man-made computers like your IBM machines and all. And there's a third category called SMC. It's called self-made computers. So you decide at the end of the session whether I belong to GMC, MMC or SMC. I repeat, SMC stands for self-made computers, MMC stands for man-made computers, and GMC stands for God-made computers. Okay? And the difference between the three we'll come to know at the end of the session. It's the attitude in life. You become either from GMC, you become SMC, and finally, you don't have to become MMC, because you don't want to become a machine. Okay. So, well, I did my master's degree in 1976 from University of Bombay in physics, way back in 76, and I'm happy to say that I was a ranker, first ranker in electronics. I had all that taken physics as the major. My specialization was in electronics, and we had about three areas like Goa and Maharashtra and the Bombay, were the two jurisdictions which were covered by the Bombay University at that time. And we had about 100 students who appeared for MSc degree in 76. We had about 40 students in electronics, and I was one of them 40. And then we had branches like nuclear, solid state, and other subjects also. And ours was the first department which was centralized in the university. The rest of the departments were all scattered. So ours was the University Department of Physics, which used to have all the lectures and practicals at one place. Okay. After doing that, I joined the university itself as a laboratory technical assistant in a program called College Science Improvement Program called COSIP. I worked there as a lab assistant for about 3 months. And then I moved to a company called International Rectifiers, which makes these power semiconductors. And I worked with them in the quality control, production, and R&D for 2 years with them. So during my tenure at 2 years with International Rectifiers, I developed an instrumentation setup for non-destructive testing of power semiconductors. And my maiden publication, which was there, the first and the international publication, was on development of AC cycle controller for surge and temperature handling capacity of a power semiconductor. It was published in Journal of Physics E, Review of Scientific Instruments, UK. After that, I left. I worked there for 2 years in the export division. I developed solid state relays, which is one of the products used today on the aircraft runways and all, so that you can light the runway. And this is the product which is used also in petrochemical plants or the cement plants, where there is a possibility of dust contamination. And if there is a possibility of arcing and if it is going to cause an explosion, then we don't use conventional switches, but we go for solid state relays. So these are the products on which I had a hands-on experience of designing them, testing them, doing the QC and doing a QA job. So that was my 2 years of experience with the International Rectifiers. So we had a collaboration called Ratan Shah International Rectifier, RIR. So I worked with them for 2 years. In the meantime, I was selected to IIT Delhi for work, doing a PhD in the energy studies with Dr. Malhotra, but then for some reason I could not go there, and I had to switch to University of Bombay. And there was a center called Western Regional Instrumentation Center, which still exists. It was initiated in 1976. The actual recruitment took place in 1978, and I was the first person to join that way back in 1978, in 7 September. And I worked with Western Regional Instrumentation Center for almost 31 years, from 1978 to 2009. And I started with this as a scientific officer, and I became a senior scientific officer. Then later on, I was made a technical officer, 1 selection grade, all these were adjustments done for putting you in proper scale. Then I was selected to be a professor, which is, we call it as a technical officer 3. And that I was there from 1995. Now, during this period, from 1978 to 2009, I had the opportunity to work on a number of areas, like right from I started developing teaching aids. My first project was developing a teaching aid for physics. And I developed an instrument called RICTRON. RICTRON, the first word WRSC stands for my organization, and Tron is the way we are electron, so we have a RICTRON. And that instrument was my first instrument, which I call it as my first embedded system developed at that time in 1978. Then the second instrument work was on Cycron. Cycron was for measurement of human reaction time and the ability to perceive time for applied psychology department. So that was my second area I got a chance to work. And my major work has been in the oceanography. So I've been working on water level detection, particularly sea level detection, and my instruments are there all over the country in India. The entire west coast and east coast instruments called digital tide gauges are located. They have all been designed by me and my group. When I say me, please understand it's my R&D team. There are about 4 people who are there in my R&D team, so we have been working with them. So although I had done my physics, I never got an opportunity to teach physics. I had to work in whatever area I had to look into. We used to basically, we are not a teaching department. Our inspiration center is basically an R&D division, R&D center. We develop products, we develop teaching aids, we do instrument maintenance programs, we do instrument calibration, and all these aspects we look into. And we also do what is known as the SRS, that is the basically software system requirement studies and analysis before you take up any project in hardware. With this background, I would like to start. I had a membership of, I'm a board of studies member for 3-4 universities in India. I'm a permanent member for the Sea Level Measurement and Monitoring Committee, the Government of India, which looks at and also a member of Disaster Management Committee in case of the natural disasters which take place. Fine, so I developed around 38 embedded products. I never called them embedded products because at that time the word embedded was not there. So now I look back and I say, okay, they satisfy the criteria of an embedded product. And one other project which I am now currently working on is on a development of a mobile phone based pulse oximeter. The idea here is that everybody has a mobile phone with them. And pulse oximeter is an instrument in a hospital in ICU. It's basically used at the time of surgery and anesthesia. But the pulse oximetry as such has a lot of applications when it comes to real world. That is, if you are having a breathing disability, I mean you're not able to breathe properly because of lung disorders, or if you have got heart inefficiency, heart pumping is not adequate, then ultimately it results into lack of the lowering down of your oxygen level in the blood. And I'm trying to monitor the oxygen level by using a fingertip sensor, so which is, or the earlobe sensor, or a forehead sensor. I'm sorry to use the word sensor, it is not a sensor, it's a transducer. Because transducers mean sensors and actuators, both. So like for example, a photodiode which detects light, or a phototransistor which detects light, is a sensor, whereas light emitting diode, which could be infrared, green or the red, are the actuators or effectors. The correct word is effector. So transducer is a broader word, and under that we have sensors. If the input of the instrument is sensor, if the output of the instrument is called actuator or effector. So with this background, I started classifying sensors not from point of view whether they're active or passive, but I started classifying them on the point of view what type of signal they generate and where the information is embedded. For example, if you take a pulse ox transducer, it has got a sensor which is a photodiode sensor, wide area photodiode sensor, and it has got 2 actuators. One of them is an infrared LED and a red LED. And when you put a fingertip in between the 2, I get finally a signal coming out from a detector which has the information contained not only in its amplitude but also in the frequency of the signal. So I also designed data acquisition systems based on the type of signal information where it is present. Is it the amplitude aspect of the signal or is it the frequency of the signal? Based on that I have intelligent data acquisition systems which will look at the signal and extract the relevant information from it. So that's what exactly I started doing, tabletop models of the instrument, and one of my models which I designed was for Larsen Tribune. I think when the slide goes on, you'll be able to see, yeah, this being product. And you can see that the assignment came to me on 26th of June 2000. That's the time the company approached me and said, okay, they have already product on the line, and they want to indigenize that product. So the requirement was given to me to convert that into indigenous product. Because they were depending on one Israeli company, called Nelcore. And Nelcore is to sell them modules for the pulse ox transducer and associated electronics. And the output used to come on a RS-232 bus. So then you have to do cosmetics like putting an LCD interface and then read the data and then putting it on the screen. But my job was to make totally the entire technology was to be converted into something which can be done in India. Of course, I must admit that we don't have competence in India to develop transducers. In fact, we may develop transducers, but we don't have an ability to package them the way the Israelis have or the way the US has them. The way you package your sensors is more important than the sensor itself. Okay, now my next job, now what I have targeted in my mind is the pulse ox instrument which is there in an ICU and is only used at the time of surgery and anesthesia. Actually, the medical, I have talked to a number of doctors and they say it is really required in day-to-day life. To give you an example of it, if you go to Himalaya and if you are not able to breathe properly, you will find you will be suffering from what is called hallucination. And that is exactly caused by lack of oxygen and your reduced ability to take already the reduced oxygen is sufficient enough. Then when you do aerobic exercises in the real world, you have to be very careful about what is your oxygen level and what is your heart rate beating at. If it beats too fast, it's bad. I mean, you must have seen those cycles in your exercise room. When you drive that cycle in sitting position, your heart rate starts increasing for whatever it is to a higher value. Based on your age, you are not supposed to allow the heart rate to go beyond that. That's one part of it. Secondly, you must also ensure that your breathing capacity is adequate. Even if your heart beats properly, all that heart is going to do is pump enough blood into your peripheral organs. But if your oxygen intake is less because of your reduced lung capacity, you have difficulties there. That is because although your heart is beating properly, there is not enough oxygen in your lungs so that when the transportation of oxygen takes place through your peripheral organs, through the blood, you find that there is a deficiency of the oxygen. So we have to see that your heart rate is good. You have to also see that your lung capacity is good and ensure a proper health for you. So you can understand there are a number of applications in day-to-day life where you have to be cautious about not only what your heart rate is, but also you have to know what your pulse rate is, and you have to also know what is the oxygen content in your blood. And that is the reason I want to make this product into a mobile phone based product. The idea is people will wear wristwatches like this or a ring like this all the time. Now, in a ring, on the top there will be infrared diode and a red diode. At the bottom of the display there will be a detector. You wear this ring, the detector will generate an output signal, which using a Bluetooth or a Wi-Fi, you are supposed to transmit it to your mobile which you are wearing in the pocket. Is it understood? There is no